Okay. First of all, this is notation for this matrix. Semicolon separates rows, commas separate numbers in the rows. So there are no commas in the matrix, no semicolon, but when it's written out in this form, which is about the only way I can actually type the form in without going through a lot of really obnoxious formatting, you have to know how to translate that into a matrix. Okay, so that's it. Okay, now this is a set of answers to the first question on a particular document that, unless you're in my class, you wouldn't be aware of, but it's very straightforward and people didn't have any trouble with it. So let's move on. So the next question, though, was if the augmented matrix for a system reduces to this, then what is the solution to the system? Well, in the first place, if this is an augmented matrix, we see that we have three variables because we have three columns before the last column, and the last column represents whatever is to the right of the equal sign. So if our variables are x, y, z, this tells us that x equals 3, and this tells us that y equals 0. So we have x equals 3, y equals 0. Now if we stop there, we haven't quite comprehended the entire solution because we also have z as one of the variables. Okay, it has coefficient 0 in both equations, but there's still variable z, or we wouldn't have this third column here, and we wouldn't have a fourth column over here, so that our third column represents z. So what can we say about z? Well, the value of z doesn't matter at all, because this is x plus 0y plus 0z equals 3. 0z is 0, so it's not going to affect this equation. Similarly, in this equation, z would have coefficient 0 in this equation. So whatever the value of z is, it can't influence the values of x and y. Meaning that no matter what the value of z is, as long as x is 3 and y is 0, we have a solution. So z could be any real number. X would be 3, y has to be 0. Okay, next question. We have the augmented matrix for this system here. And it's very easy to see that that's the augmented matrix, and if you don't understand that, look that up. But we just put the x coefficients in the first column, the y coefficients in the second column, the numbers on the other side of the equal in this column, and we have an augmented matrix that we can then reduce. And the steps of that reduction mimic steps that we could take in reducing this equation, or this system of equations, to find its solution. So the first thing I do, and I'm not even sure I solved the system correctly, I might have. I did all the numbers in my head. But the first thing we do is we take 1/2 of the first row, which is going to give us a 1 here. Okay, so we do that. That's the operation. And that's the only thing we've done to the matrix. But then we come over here and we use the 1 in this first column to wipe out the 4 and the 5 here to give us zeros. In order to do that, we add negative 4 times the first row to the second. And if we do that, I believe we get this. You can double check me on that. Then if we add negative 5 times the first row to this one, that's going to give us a 0 here. We can lock that in, and I think that gives us this. Then I simply divide this row by negative 8, getting this. Divide this row by negative 2/7, or multiply this row by negative 2/7, and I get this. Okay, and if I did my arithmetic correctly, I have now a matrix that represents this system of equations. Now what's wrong with this system? Well, what's wrong with this system is that it's inconsistent. Okay, this equation tells us that y is 15/8. This equation tells us y is 25/7. If that isn't inconsistent, I'm not sure what is. So we have a set of inconsistent equations, and there's really no point in reducing further to get a 0 here because we don't really know which one of these rows we ought to use to modify this row, and they're going to give us different results. So at this stage we say, well, okay, that system is inconsistent, and it should be obvious why. Okay, then next question, I didn't number it, I think it's number 4 if you're following the worksheet. But you were given this matrix, this reduced matrix, and asked what this matrix says about your system. Well, if this is the reduction of an augmented matrix, and again let's specify that this is an augmented matrix, otherwise we'd have a completely different interpretation. If this is an augmented matrix, then it tells us that x equals 2, that y equals 6, and that y equals 3. And obviously y can't equal 6 and 3. So again, we have an inconsistent system, a system with no solution. Okay, now there's a question about what can we say about the coefficients A, B, C, and D if this matrix reduces to this matrix, and we'll get that in the next video.